Friday we talked about domain, we talked about vertical asymptotes, and we talked about horizontal asymptotes. Okay, so we always said that the first step we do when we're looking at a problem is we're going to actually factor this problem. So this will be x minus 3, x plus 3 over x minus 3. Correct? All right. So notice that this one has x minus 3 in common. Earlier on Friday we said that the domain on this one was what?
All real.
All real except for x not equal to 3. What was my vertical asymptote on that? It's NA, right? Because we canceled it out. There's nothing on the bottom there. But what happens is the one that's on the bottom there becomes the whole. So if you've canceled it out and you don't have the vertical asymptote, that becomes the whole in this case. So this would be x equals 3. Okay? So at x equals 3 on the graph, wherever the graph crosses x equals 3, that's going to be a whole. I'll show you that in just a second. Do we have a horizontal asymptote on this? It's a slant, right? The horizontal asymptote, because this is a degree of 2 over a degree of 1, and 2 is larger than 1, we're going to have a slant. Okay. First of all, one of the things I want you guys to notice is that after I cancel this out, I have y equals x plus 3 left over. You guys see that? Okay. I can graph that line. Where's my y-intercept on that line? At 3. So 1, 2, 3. I'm going to graph a point here. What is my slope on that line? 1. So I'm going to rise 1, run 1. So I can draw a line going through there like this. Now earlier we said that there's a hole at x equals 3. So what I need to do is move over on the x-axis to the 3 until I cross, and so at 3, wherever it crosses the line that we just drew, and it happens to be on the x-axis, I can draw an open hole there. Oh wait, I'm sorry. Yeah, I did it backwards. Undo. Okay, at 3, here's 3 over here. Go up to the line at 3 and draw an open hole there. Sorry about that. Okay? So what a hole is where this line is continuous until right till you get to 3, and then it has to jump over a gap and then continue going. It's a select point that it cannot be. Yep, it's undefined at that point. This is actually on your homework sheet. Number 4. I need to factor both top and bottom on this. So that would be, on this case, it would be x minus 3 and x minus 2. Okay? On the bottom, it's going to be x minus 3 and x minus 1. Okay, so if you want to know how I got that, if you think about, okay, so negative 3 plus a negative 1 is going to be a negative 4. Okay, and you can do the box method to solve that if you need to. All right, so here's our factors. I can cancel out something. That's that one, correct? Okay, so for number 4, I know that my domain, first of all, is what? It's all real numbers except for x equal to what? 3 and 1. Okay? My vertical asymptotes are going to be what? What wasn't canceled out?
Negative 2.
Yeah, this x equals 1. So that's my vertical asymptote. My whole is going to be what? X equals 3. Okay? Now, our horizontal asymptote in this case, notice that they both have a degree of 2. They're equal. And remember, if the degrees are equal on top and bottom, you're taking the coefficients in front of that, and that's what your y is going to equal to. So what are my coefficients, even though they're not listed there? 1 and 1. So what's 1 divided by 1? 1. Okay? So it has a vertical asymptote, it has a horizontal asymptote, it has a whole.
How did you get the whole?
The whole is the one that was canceled out.
So if there's not one canceled out, that means there's not.
Right. If nothing was canceled out, there is no whole. And actually, this one should be a minus, because that's from your note sheet, okay? So now I want to talk about how to find your x-intercepts. How you find it is you're going to put in a 0 for y, and you're going to solve for x. Remember that I can actually rewrite this top part as the factors of x minus 3 and x plus 3, correct? Okay, so what I am left with here is, if I cancel those out, I'm left with 0 equals x plus 3. So what is my x-intercept in this case? Well, if I subtract 3 from both sides, it'll be negative 3. So my x asymptote, I mean not my x asymptote, my x-intercept is negative 3. On this one right here, y, I need to set all my x's equal to 0. So this will be y equals 0 minus 9 over 0 minus 3. So what is my y-intercept? 3. So going back to our homework example for today, my x-intercept is where y equals 0. So I've crossed these two out, so it's going to be 0 equals x minus 2 over x minus 1, correct? So if I get rid of this denominator, I'm going to multiply both sides by x minus 1. 0 times x minus 1 is what? 0. So I'm left with 0 equals, and these cancel, x minus 2. So what is my x-intercept going to be?
2.
So that's my x-intercept for that one. Now, if I want to check for my y-intercept, don't have a lot of room here, do I? Y is going to be, notice I'm going to replace all my x's with 0. So x squared becomes 0. Minus 5 times 0, which is 0, plus 6 over 0 minus 0 plus 3. So what is my y-intercept? 2. Okay, first of all, what was my vertical asymptote on this one? 2. So I'm going to draw vertical asymptote at 2.
Oh no, it's 1.
It was 1?
Yeah.
Oh, it's at 1. Sorry. So at 1. Okay. What was my x-intercept? It was at 3? I don't remember. I have to go back. Yes, if it's an asymptote, it's a dotted line because it's an imaginary line. Okay, so x is at 2 and y is at 2. Okay, so those are my two intercepts. So I'm going to have a dot here at 2. and a dot here at 2 also. Okay? And did I have any horizontal? What was my horizontal asymptote? It was at 1, right? So I'm going to draw another horizontal asymptote right here. Okay? At the 1. That one's horizontal. So, yeah, it's good to try other points. But as a guess, I'm going to guess it's going to look something like this. And I'm going to check my work. So on this app on Chrome, it's called Desmos, D-E-S-M-O-S, okay? You can actually graph this and just check your work. And that came very close to what I had. All right. Okay, there's one thing we're missing on our graph. It's the hole that we found, which was at 3, right? So if we go to our Desmos graph, we will actually see that. If I scan over the 3 and I keep going to where x equals 3, generally it will tell you, yeah, right there. It will tell you it's undefined. So look, do you see it say undefined? Okay, so that's because there's a hole there. All right, so now if I go back to my actual sketch, I'm going to make sure that my graph at 3 here, I'm going to put a little hole there by putting an open circle. Yeah, there's nothing there. It jumps. So that's how you account for the hole. So the last little bit I want to talk about today is continuous or discontinuous. Does this graph look like it's a continuous graph? Really? What happens when I get to here? It goes on forever up north, right? But then all of a sudden it comes from the south. So it's almost like it went around the entire globe and came from the south, but that's not actually what happened. Think about it. You had to jump that asymptote somehow. So in order to get from here to this side, it's discontinuous. Okay? Not only is it discontinuous because of the asymptote, but it's discontinuous because of that open hole there. When I approach 3, I got to take a step over that hole. Otherwise, if I were skating on it, I would fall. You know, I'd hit a hole and boom. Yep, if it's a hole, it's discontinuous. Or if you have a vertical asymptote, it's discontinuous.